Hi, everybody. Welcome. So I did send a text earlier about making sure that you do have some pencil and paper. We will be having some notes today. I'll let you know what's important to copy down. And I just wanted to send a reminder. So today we're going to talk about distance, velocity, acceleration, because there were some questions on the 2012 AP practice exam that had some of this. I want to make sure we cover that. Um, Session will be recorded. Our usual class norms: active listening, be kind, respect different ideas, participate for sure, and again, be present. I will be again putting in today's Zoom for participation as well into the Power School. So do make sure you participate when prompted. So use the chat to share ideas. No one has yet used the raised hand to speak part yet, but feel free to. And try to refrain from multitasking as hard as that may be with our different situations. Here's our agenda. We're going to have a check-in question. We have some notes with an examples on distance, velocity, acceleration. I tried to shorten it and just be like straight to the point so that we just get what you need for the exam. Again, the exam, I'll talk a little bit about that in a sec. We do have a task today. It's due on Google Classroom by 11:59 p.m. So that's our agenda. And this is, you always just want to go to your virtual calendar on Google Classroom to see what's up. Again, I'm still preparing the lesson for Wednesday, but just as a heads up, because we only have tomorrow and then we have a little bit of next week, I think, and then after that, it's going to be your AP exam because the AP exam is Tuesday, May 12th at 11 a.m. So we only have like a few days before the AP exam is going to start. So a lot of it's going to be kind of like a lot of AP exam review questions, or also learning some things that we haven't gotten to that we should learn before the AP exam. So that's just a rundown of what's happening the next 2 weeks. Again, May 12th is coming up to us really quickly. And again, Tuesday, oops, sorry guys. Um, Tuesday, Thursday, and Friday, I don't assign anything. So feel free to use Thursday and Friday to like study extra. There's a lot of resources online to study for the AP exam. Up to you, right? And or if you need to catch up on any of the missing work, I would use Thursday and Friday. We do have a lesson on Wednesday. I just need to put it in there. All right, we're going to be jumping into our check-in question. All right, our check-in question today is, what is something that you like but everybody else hates? And it could be about anything. So one thing that I like that people hate probably is this candy, Abba Zaba. I don't know if you've seen those before. Um, I really used to like the vanilla taffy with the peanut butter filling. A lot of people think it's like really weird, but that's a candy that I've liked in the past. But yeah, that's something I like that most people are like, what? So feel free to go ahead and participate in the chat. So what is something that you like but everybody else hates? It doesn't have to be food, it could be anything. The dark. Yeah, some people be liking the dark, even though, yeah, I probably would not want to range through there. Thank you, Kiara, for participating. Let's make sure we all get our voices in there. And it's okay if you don't know, just put you don't know. Staying up late? Yeah, you're right. A lot of people like that. I really hate when they do that, though. I really mess up my routine. That's a good one, Alexa. Doing nothing. Yeah, I hate not I also don't like being productive either, if that makes sense. Yeah. A lot of people are like, "Yeah, I'm gonna do nothing." Well, never mind. You like doing that, Eric. That's good. Um, I like being productive, but then there's days when I feel guilty when I do nothing, but I think we should feel okay with doing both. You like both, but yeah. Okay. Great. Thank you, Kiara, Alexa, Eric, so far for putting your voice in there. And again, if you don't know, feel free to put IDK. Doing homework early. That's something you like that everyone else hates. That's good. And then Rafa, not sure. That's all right. Yeah, a lot of people like to put off their homework to the last minute. I agree. And then saying you don't know, Elizabeth, not sure. That's all right. Cool. Thank you guys. And again, as a reminder, do make sure that you have some paper, pencil. We're going to be doing a few examples today in today's lesson. Let's go ahead and jump into it. So this is what today's assignment looks like, and it's on Google Classroom. It's due today, 11:59 p.m. And it looks like this. Let me just let this load. So this is what the assignment looks like. You're going to be given a distance function, and you're going to be asked things about like average velocity, what is the velocity formula, what's the velocity exactly at 3 minutes, what is acceleration formula. So hopefully by the end of today's meeting, we'll kind of know the answers to these questions. For this, at the moment, we don't have to open up this task, but I'm just showing you what's going to be due today. And at the last two questions, though, I put in number 6 from the AP exam 2012, a question from that to see if you could apply today's knowledge, and also number 28. But notice how it has sine, cosine. For that specific problem, I put in the unit circle as like something you might need to answer that problem. So I stuck this in here. And then remember, guys, the AP exam, it's going to be open notes. So you're free to like have the unit circle by you, which is really cool because in the past, they would have you memorize the unit circle. So it'd be cool to just know what resources you need to have ready for when you do your AP exam. So that's today, and it's gonna be due today. Again, it's just an attempt, and we're gonna have some notes. So have that ready. Let's see what's next. Yeah. So we're gonna be jumping into our notes. I'm gonna be going over to my PowerPoint, which is over here. And if I'm going too fast or whatever, just let me know in the chat. I will be also recording this, so you could always just go back and look at the examples. But here we go. We're going to be talking about the derivative and the traveling object. So basically, the learning target is I can connect the derivative to a moving object. And again, sorry if you, let me know if you want me to slow down, but I will be uploading the recording by 5 p.m. or sooner, by like 3 p.m. But here we go, everybody. So when you're driving a car, right, you check the speedometer. That little thing that's right below the wheel, right? It tells you the speed that you're driving at. Is the speed that you're seeing an average speed, or is it your actual current speed? Go ahead and put that in the chat. What do you think you're looking at when you're looking at the speedometer? So Eric, you put current speed, so the actual speed at that moment. Great, good. So a lot of you, Betsy, Kelvin, y'all are agreeing that that is your actual current speed. Perfect. Great. So we're right. And when we're talking about great, when we're talking about that current actual speed, we're talking about instantaneous speed. And whenever you hear instantaneous, that's going to be the slope of the tangent line or the derivative. So it is your instantaneous or your current actual speed. Yes. So that's what we're looking at. So basically, if you want to know exactly how fast you're driving, you're going to be needing to take the derivative because that's going to give you the instantaneous speed. So again, when you're measuring speed at an exact point in time, this is called instantaneous speed, which occurs at an exact point in time. That's when the derivative comes in. We've used the derivative to find the slope of the tangent line to a curve. Now we're going to be applying it to, instantaneous rates of change, like when a car is moving. Okay. And again, if you need me to slow down, if you're writing this, let me know. And just use the chat there. Okay, so usually on the x-axis, that's going to always be time. And usually it's going to be given by a position function. It's funny, but even in the AP exam, you're going to see that when they're talking about a position or a distance function, they're going to use s, like s of t. And the t is going to be time, and the s is your distance on the y-axis. So y-axis is distance, t is time, usually when it comes to distance time graphs. And again, they usually use s to represent that function. And velocity has a notation v of t, and then acceleration has a notation a of t. So those are just like, some stuff to know. Okay, so here's a kind of an example that we're gonna be looking at. So say that you travel in feet by a car, You travel in feet by a car. Okay. The distance that a car is traveling in feet kind of sounds better. Is modeled by this function, s of t equals 3t squared minus 6t. So we have this function. Represents the car's distance. T represents time, but I don't know if it's seconds or minutes yet. Didn't say. But what I did is I just used Desmos and graphed it. Again, because the AP exam is going to be open note, I think they're going to be letting you use Desmos. So that's a tool you could use for the AP exam as well. So I took this, I put it on Desmos just so I could see like, okay, this is how the car is traveling. Like, it's just a model of it. And we want to find, so one of the questions you might be asked in today's task is what is the average speed / velocity traveled between t equals 2 and then t equals 5 minutes. So it looks like t is in minutes then. So t is minutes. Okay. So 2 minutes. So this is 1, 2, 3, 4, 5. So here's 2 minutes. And then 5 minutes is over here, but it looks like my graph kind of goes off. I kind of cut it, but it should be somewhere up here. So here's 2 minutes and the 5 minutes is somewhere up there. Basically, if you drew a line through these 2 points, and you find the slope of that line, that's going to give you the average speed. So whenever you're being asked, like either AP exam or whatever, about average speed or average anything, that's basically always going to be slope formula. So I have 2 comma 0 because at t equals 2, right, my y was 0. But in the chat right now, I'd like you to go ahead and put in the chat, how do y'all think I got 5 comma 45, right? I couldn't see where 5 hit on the graph. So how did I get 5 comma 45? If y'all can put that in your chat, in the chat. So Calvin says plugged 5 into the equation. Eric says plugged t equals 5 into the equation. You have to plug it into the function and you plugged it into the equation. You guys are all correct. That's correct. So here's our equation. If I take the 5 and I plug in for t, 5 squared is 25. 3 times 25 is going to be 75. But then minus 6 times 5, so minus 30. 75 minus 30, yeah, that gives me 45. Perfect. Thanks, Kiara. And Alexa, you guys are in agreement. So great. That's how I got that second point. So now that you have 2 points, remember all you got to do is x1, y1, x2, y2. You plug into your slope formula. That's going to give you your average speed. So 45 minus 0 all over 5 minus 2. So my average speed between t equals 2 and t equals 5 minutes is going to be 15 feet per minute. And remember, you don't have to write this per minute. You could write 15 feet dash or 15 dash min. 15 feet per minute is fine. So that's average, right? Average speed, that's something we kind of talked about in the past, but we still haven't yet talked about how to do the instantaneous speed. For example, what if I want to know how fast am I really going at t equals 2 minutes or t equals 5 minutes? Yeah, so Eric, that's correct. So average speed is just the slope between the 2 points. But once we hit the parts of the question they're asking for instantaneous or the exact speed, that's when you're going to use derivative. So yeah, when you're asked about average, you just find the slope between 2 points. And again, if anyone's writing this down right now, let me know so I could pause at this slide. If not, like I said, I'm going to upload the video and you could always look back to these examples. Okay, so now with the same problem, what if I want to find the exact speed at t equals 3 minutes? The instantaneous speed at this time is going to, again, be the slope of the tangent line, which is the same thing as saying derivative. So again, here's the same graph. It just looks less stretched. Same graph though. So here's my function. So if I want to find instantaneous of anything, you have your distance function. You're going to take the derivative of it. Here's my derivative. Remember, you bring the 2 down, I get 6, subtract 1, so it's just t. And then the derivative of like 6t is just going to be 6. So that's how I got my derivative function. Remember, this is not integral, it's derivative. And then let me know if anyone has any questions on how I got the derivative here. I'm happy to talk about it, but that's the one where you bring it down, subtract 1 from the exponent. And now maybe if anyone has any ideas now in the chat, what will I do now? So I have my derivative function. But what do I do now that I want to find the exact speed at t equals 3 minutes? What do I do to get an actual number out of this? So in the chat, let's see if anyone has any ideas. Plug in 3 is what Alexa says, and Betsy, you also said plug in 3. Elizabeth, we plug in 3 into the derivative. Perfect. That is exactly what we do. So if I want to find the exact speed at 3 minutes, is step 1, take the derivative. Step 2, plug in what you're looking for, which is 3. So the exact speed at t equals 3 is going to be 18 minus 6, which is 12 feet per minute. So 12 feet per minute is how fast my car is going at exactly t equals 3 minutes. That's going to be like what you see at the speedometer. You're going to see 12 feet per minute. Speedometer. Let me know if anyone has any questions on this specific example. All right, let's move on. Let's see. What else do we got? Oh, we got this. The instantaneous speed is basically, by the way, guys, the same thing as instantaneous velocity, because speed and velocity are almost the same, except speed is the absolute value of velocity. So they're sometimes the same thing though. And the velocity, guys, the instantaneous velocity is the same thing as taking the derivative of the distance function. So this right here, s prime of t, that's the derivative of the distance function. This right here is your velocity function as well. So that's something very important, because the derivative of the distance function is basically this right here is a velocity function. And what we found was an instantaneous velocity right now. The 12 feet per minute is a velocity, and it's the exact velocity. So that right there is an important definition. And here's another one. Acceleration is now defined as the derivative of velocity or the second derivative of your distance function. That's how you find acceleration. So that's just some definitions there. I'm hoping we'll get to some examples. Let's see. Got about 11 minutes. Okay, so let's actually do a type of problem that's going to show up in your task. Okay, so say that the distance a car traveled in t minutes is given by this function. Cool. What are the questions? A, what is the average velocity between t equals 3, t equals 5? So remember, average means you have to create the 2 points, find the slope. And then you all already in the chat talked about how we found the 2 points. Basically, you plug in these into the function to get your points. So let's do that. So basically, if I plugged in 3 into my function, I got 9 minus 20, I got negative 11. If I plugged in 5, I got 25 minus 20, which is 5. So again, let me know if anyone needs help or clarification how we got these 2 points. But remember, whenever you see average velocity or average of anything, it's usually find the slope between the two. So the next thing we're going to do is the slope formula. Plug in. And then be careful, because for this one we did 5 minus 11. So be careful, because this double negative is going to become a positive right here. So then 5 plus 11 is 16. 5 minus 3 is 2. So for this problem, it looks like we get that the average velocity is going to be 8 feet per minute. So that's part A. What is the average velocity? These are the steps on how to complete this problem. Let me know if there's any questions on part A for this one. Okay. Great, now let's go into what is the velocity at t equals 4 minutes. Notice I'm not saying between 2 points. When it's saying what is the velocity, it means what is the exact velocity at 4 minutes. Like exactly at 4 minutes, how fast am I going? That's when you know to do the derivative and then you plug in 4. So we're gonna take the derivative of the function. The derivative, you're gonna bring down the 2, so that's gonna be 2t. Minus 20, basically minus 20 is a constant. That's just gonna go to 0. So our velocity formula is this. S prime of t equals 2t. This is our velocity function. Now the last thing we want to do is plug in 4, and that's going to give us the exact velocity. This one's interesting because in this problem, the average velocity is equal to the instant velocity at t equals 4 minutes. So this was actually a coincidence that this was also 8 feet per minute, because usually the average is different from the instant velocity. So that's just interesting, but you also get 8 feet per minute exactly at t equals 4 minutes for this problem. All right, let's move on to the other parts of this one. So there's an example too. Okay, cool. So we got some more examples here. Say that the distance a car traveled is now given by a cubic function like this one. See, it's cubic because it has to the third power. Now again, average velocity, you're going to create the 2 points. So you want to verify, right? When you plug in 1, do you really get 0? So that's something maybe that you guys can verify later on. But when I plugged in 4, it looks like I got 141. You guys can double check that work, but I'm going to go through the process so that you have at least 2 examples to work off of. So again, when you're looking for average, you're going to do slope. You plug into the slope formula. And then you simplify. For this one, it looks like, oh really, that's a perfect number. So 47 feet per minute is the average velocity. I'm hoping this problem actually asks us about acceleration, so y'all can see an example of acceleration. I'm hoping. And it says, what is the velocity at t equals 2 minutes? Can someone in the chat, because to find the exact velocity, remember we're going to be taking the derivative of our function. Can someone in the chat put in what is the derivative of our function? And the function is up here. Let's see if you guys can put it into the chat. So Kelvin, you put 6 t squared plus 5. Elizabeth is also in agreement with Kelvin. Wow, Alexa, how'd you put the exponent? Yeah, you guys are, yeah, that's correct. I don't know how you were able to do that because I don't think I could do that in the chat. Yeah, 6t squared plus 5. That's correct. And for those who are like lost on how we got that, you bring down the 3. So 2 times 3 is 6. 3 minus 1 is 2. So that's where the squared came from. Plus 5 from this part. Remember, the derivative of like a linear function, whenever it's by just one variable, it's just going to be the constant, which is going to be the plus 5. And this right here, minus 7, is by itself. It disappears. So that is indeed the derivative. And then the next thing, y'all know what to do. You plug in the 2, and then that's going to give us the exact velocity at t equals 2 minutes, which is 29 feet per minute. So now in this case, notice how the instant velocity is different from the average, which is usually the case. It's not always, they can't, like, that's rare for these two to be equal. Average is equal to instant is rare. Okay, great, thank goodness. Okay, good, we got an acceleration question in here. So again, it's the same function as before, but now we want to find out what is the acceleration. So acceleration, remember the definition, it's you take the derivative of the velocity function. So notice in the chat, y'all put in that velocity function, 6t squared plus 5, that's velocity function. If you take the derivative of that, it will give you the acceleration. For those of you who understand that, can y'all put what is the derivative of the velocity function? So what's the derivative of this? So Alexa, you put 12t. Elizabeth is also saying 12t. Betsy's saying 12t as well. Great, Eric. Awesome. So it looks like we're in agreement so far. And again, if you're lost, again, how we got 12 t's, you bring down the 2. 6 times 2 is 12. T plus 5 goes away. So it's just 12t. So basically, that is your acceleration function. So once you've taken the derivative of velocity, that is the acceleration function. Now, the reason why I put this right here is to show you that this middle part's right here. This is me showing you that the derivative of distance function is velocity. The second derivative, so like taking this derivative 2 times of the distance function, is acceleration. So that's why I put this in here so you can see that. So it's saying acceleration at t equals 2 minutes. That means I'm going to plug in 2 only into the acceleration function. So it looks like acceleration is going to be 24 feet per minute squared. So I don't know if y'all remember that from physics, but usually acceleration, the time is squared. So feet per minute squared. I could like kind of talk a little bit more detail on that next time, but it is 12:58. So I know you guys have government to go to. Can you please, if you were here, if you could put here into the chat just one more time. I know some of you were participating, some of you weren't though. So I want to make sure I'm giving credit for those who are attending. So if you could please put here into the chat. Thank you, San. Thank Rafa, Alexa, Kelvin. Great, I got you guys. Yep, Eric's here with a little heart. Betsy's here. Elizabeth. All right, y'all, thank you. Again, please make sure that you put your here. So I could give you all credit. I'm also going to double verify this by just making sure I take a screenshot of your names. All right, y'all, enjoy AP Gov. Let me know if you need any help and stuff. I miss seeing you guys. Enjoy. See you later. Bye.